Wait, I have something I want to say first. Okay, so I think the first thing I know, right, is I just want to check, right, how many of you here are web developers or specifically front-end developers? Okay, some. Okay, so hopefully not everyone is lost. So this thing that I'm going to present today is fully based on my own personal experience, my own personal project. I do use the library that I built in production in my own company and my own projects. So, but still take it with a grain of salt. And I would like to get your help to help me bash it and try to destroy it so that I can learn from it. Yeah. Okay, so today I'm going to talk about this. What if Fetch API could be better? Okay, and it's based on this library that I wrote called Simpler Fetch, because all the other names to do with Fetch are taken. So, yes. So hi, I'm JJ. I'm currently a software engineer working on this thing called the PMF2.com. And it's based on this API library that I built called Simpler Fetch. Oops. Because I'm like every other developer out there, if it exists, it is not good enough for me. So I'll build a new one. So yes, I built a new one. So the problems with Fetch, right, is that although it's a great replacement from the old days of XML HTTP requests, which that was just horrible, right? But now there's a new one which is better, but it still can be improved, right? And these are the three main problems that we still face today that I want to try to tackle with my library. So the first problem is that it's hard to use API-based URLs, especially when you have multiple of them. So for example, if you have version 1 of an API, version 2, version 3, or different other base APIs, let's say if you are not using an API gateway, you have your billing API, your usage API, and whatnot. So that's a bit hard to use with what we have right now. The other thing is exceptions handling. So exceptions are different from errors and they should be handled differently. Whereas in JavaScript, the tradition is that every time you have something that you don't like, you just throw it. Right? And we want to not have that because throwing things are like go-tos and bad. And the last thing is that, can I just check how many of you here use TypeScript? Okay, so some people use TypeScript. So TypeScript is great, right? But the issue with TypeScript is that it's compile time, and TypeScript, it can be, we can try to modify or try to like tell it things that like, trust me bro, right? For example, you can say as unknown as type. Whereas like actually it's not really that type, but you can cast it to think that it is a correct type. So it's not really very nice to use, especially when you try to like, you want to trust that data. So we want to do something about it to add type checking. So the first problem, hard to use API-based URLs. This is the problem. Most of the time, right, if you don't have a proper way to handle base API URLs, you see many projects will just do string interpolations or even string concats, which is not very manageable and scalable at larger scales. And most of the time, projects usually start small and then this is fine for a while. And as they grow, it becomes harder and harder to manage and becomes more and more complex. If you change somewhere, maybe something break. If I accidentally add a slash here, there's 2 slash, it might break. So lots of issues there. So we want a better way to deal with it. So this is my solution. How it works is that you define what are the base APIs that you want over here. So you can add a new base. SS stands for Simpler Fetch, it's a library name. So you can say, okay, I want to say that for version 1, it is localhost 3000/v1, version 2 is this, and I can also add like my different endpoints for different services, let's say Stripe or whatnot, which you use for payments. And the last thing is that I can set something as a default one. So for example, if most of my APIs are on version 1, my default will be version 1. And to use it, the way you use it is, you can say, okay, I want to use the default API-based URL, and then that will be your version 1, which was set at the bottom there, set default. If you don't want to do that, let's say you want to use another base URL, you can say use base, and you can use the version 2 base URL. So version 2 here, and then you can use this base here. So this allows you to use different base URLs easily. And if you really don't want to use a base URL, you want to use a full URL, you can also do it like this. So the reason is because many times we want to integrate with external systems, we want to do one-off integrations. We don't really want to add that as a single base URL or a new base URL to like add to your collection of base URLs. You just want to make a one-off call. So this makes it easy for you to do that also. The second problem is exceptions handling. So some of you may be wondering like, why am I not saying error handling? Right, so it's because exceptions are not errors, therefore we should not treat them as such. Right, so the key idea here is that errors is something that shouldn't be recoverable. So for example, a classic error that you guys have heard of is like out of memory error, right? Once your computer runs out of memory, nothing can recover from that. Of course, I mean, the program itself cannot recover from that. Exception is something that you can recover from. So for example, if user types something invalid, you want to tell them to try again. So that's a user input validation exception. So that's the main difference between them. So these are some of the examples of exceptions in the API calls. For example, a 404 or 500. If you have a 404 code, that just means that the thing is not found. Maybe the user requests for a wrong resource, or they search for something invalid, but it shouldn't be an error because this is something that is recoverable. And 500, it just means that the server may not be able to respond right now, but the server can respond in the future. So it also shouldn't be an error, it should be an exception. And example error is, for example, linking back to the first problem, if you try to use a base URL that does not exist, that's an error because you should fix that when you're writing the code. It's not something that you can write more code to fix. You should fix it before you even deploy the project. So the issue is that Fetch and most other API libraries, they treat errors and exceptions as the same thing. Basically, every time they see an exception or they see an error, they throw it. The issue with that, right, is that if you have things that are just being thrown randomly, you need to write extra boilerplate code using try catch or like .then .catch to try to handle it. And the issue is that once you have those, it's very hard to narrow down specifically to what is the specific exception and errors in order to deal with them differently, because you want to deal with a 404 and a 500 differently. And throwing errors and exceptions and using try catch blocks are in essence just our advanced go-to statements nowadays in JavaScript, which is not very good because it's harder to read and understand. So just an example of how it looks like. This is a very simple example using fetch. If you try to fetch some data here, and if it throws, you'll be left here, right? And over here, you may be wondering like, hey, what's the issue? Is it because there's a network issue, a DNS issue? Is it because of some formatting issue or whatnot? So this is a very simplified example, but there could be a lot of error all thrown into a single catch block for you to deal with. So what's the solution? Solution is because I really enjoyed Rust result type and Go's way of returning multiple values, multiple return values, so you can return both result and error, and you can treat them sequentially just like any other value instead of using try-catch style of non-linear control flow. So this is an example of Go code where you get back both your results and error, and then you check whether there's an error before you move on. If there's an error, you may choose to not move on, or you may choose to do something else. So why can't we do something just like that for API calls? So you can. With my library, what you do is after you make the API call, you'll get back both a result and both response and an error. So here you can check, hey, is this error undefined? If it's not undefined, it will be type narrowed to request exception. And here you can like go and figure out what type is it. You can use your instance of check in JavaScript to figure out what type of error is this exactly. And after that, over here is when there is no exception, but it's you get back an actual response from the server. Of course, the response from the server can either be a 400, 500, or even 200, right? So for most libraries like Extros and whatnot, they treat any 400, any 500 as an error, and that will be handled at this point. But what you in fact want is not that. You want to treat it as a response, as a proper response that you receive back. It's just that over here, that the response.ok is different, which is based on the fetch standard. If the response is okay, you can access the data. If the response is not okay, you shouldn't access the data, right? So that's my solution for exceptions handling. So the last problem is response type checking. Okay, so what's the problem with response type checking? This is a big issue, right? Okay, so you see most API libraries and fetch, they lack the proper response validation, or they don't have an opinionated way of doing it, right? Some will say, oh, you should just use Zod. Some say, oh, use Joy or whatever other validation library that you like, right? So, and the thing is, sometimes people just don't care about it. People just say, okay, you know what, I trust my own API and I'm going to use, since I'm using TypeScript, I still need to ask TypeScript to trust me. So usually you'll see code like this as something, right? So this is your expected response type, you say as this. So essentially, for those of you that don't know what this means, this is just telling the TypeScript compiler, hey, trust me bro, I know what I'm doing. This is the correct result type, and your to-do will be casted as expected response type. Even though this to-do can be any other value in the world. It can be a string, it can be a boolean, but you'll always be casted to expected response type. So that's not great, right? You don't wanna just trust me bro everywhere. So my solution is you allow users to pass an optional validator here. So they can use Zod, if you like Zod, you can use Joy or whatever other response validator library that you like. And once you validate it, and you have your expected response type here, when you use it, you cannot just be sure that it is definitely expected response type at compile time. You can also be 100% sure at runtime that it is expected response type, and it cannot be any other type, because if this did not properly validate, it will be an exception over here, and it will be a Zod error. Okay, so here I'm using Zod. If you use any other library, it will be your library's error class. Yeah, so with this, now every single API you call with this runtime type checking, you can guarantee yourself that whatever type you use at compile time is actually correct and not just some random type that you're using, which can be changed halfway later. So okay, so why not X? Just now when Jody said I'm building another fetch library or my own fetch library, some people are like, oh, you know, why? So yeah, why not any other fetch library? Okay, I have a very biased take, okay? So because I think that my library has a better developer experience, the primary thing being the builder pattern, where you get to chain methods together to build your final API calls, the ability to safely handle exceptions as values instead of having it thrown, you get it returned to you and you can handle it sequentially without being nested in any try-catch block or dot-catch anonymous functions. And lastly is that you can get better type checking that is actually valid both at compile time and runtime. And the second thing is that at first I wanted to build on top of other libraries like I say Axios and Super Agent, but the issue is that they are already huge, right? So I want to build something that is simple and easy, not very highly abstracted, and just enough to make it ergonomic for you to build things on top of. That's why I created a simpler fetch, so it's a bit smaller also. Okay, so why not Axios? So Axios, as you can see, it's a lot harder to properly handle it because they nest everything in the catch blocks. So if you want to share any code between the then and catch, you can't really do that. And if you try to return from this catch, you'll just end up finishing this Axios.get call without actually ending the get data function. So there is no easy way from this .catch block to easily escape out of this get data function also, which makes certain flows harder to reason about. And why not Super Agent? Super Agent has a lot of the same issues that I talked about with Axios, and I think is that it's hard to manage base URLs. Even though Axios have like a plugin for you to use, this is a community managed plugin from 7 or 8 years ago, and it is still based very heavily on using your own strings and trying to interpolate them. Okay, and this is the same issue as just now, where let's say you have some data you want to share between these two, is very hard, and if you return something from catch, you can't escape out of the root function. You'll be stuck inside the catch function. Okay, to conclude, what is missing from my library? There's a few things missing because it's small, so it has to forego some nice to have. The first thing is that there's no auto polyfilling. So if you're building for Internet Explorer very old version, then you need to auto polyfill your own fetch. We don't provide fetch. There's no automatic retry mechanism, which many modern fetch library gives, let's say Axios or whatnot, but most of the time, I don't see any use of it. Not that there's no use of it, but I don't personally see any use of it in most projects. And lastly, there is no support for custom abort controllers, because most of the time abort controllers are just used to support custom timeouts, and the library already supports custom timeouts, so there's no support for custom abort controllers. So these are the key features that we just talked about. How do you manage multiple API URLs easily? How do you have an easy way to handle exceptions as value? And how do you get proper type support, not just at compile time, but also at runtime? And that's it. Thank you. So yeah, if you have any thoughts on how to tear this down or try to like break whatever I'm saying, please let me know. I would love to learn. Yeah.
Questions? Cool. And you have a question? So you ask yourself why not X, Axios, and Super Agent. So when I'm building something, usually I just go for fetch because it's easy, I don't have to pull any dependency. But when I need something more advanced, I try to get as much feature as I can. So when I need a library, I need to know the error state, the loading state, this kind of stuff. And so I would probably reach for something like 10-stack query.
Yeah.
So it comes with the same safety. You have the ability to plug in your own resolver as well to use Zod. How do you compare to libraries that are more feature complete?
Right. Okay. So that's a great question. So to repeat the question is more about like why not use a library that's more feature complete? Why use mine, right? So the key thing to me is that most projects don't need most of the features that you're talking about, right? So some features, let's say loading states or whatnot, those are very nice to have. And okay, let me just do a quick divergence. So regarding 10 stack, right? Some of you may have 10s stack or React query. You can use this library with those. So because this is just a query function to load data, and that will still take care of your different JSX states or whatnot. So the key thing is, why don't you use a more complex or feature complete library like Extras and Super Agent? It's just because like most use cases don't really necessitate that, and Extras and Super Agent, they are generally very big, and they are big enough to a certain point where like it's hard to understand how to use them, it's hard to onboard them, especially if you're not familiar with it. So I worked at a few companies in the past. Some of them prefer Extras, some of them prefer Super Agent, some of them run their own thing. So every time when I look at them, I have to go and relearn the library, and it's hard to get on board. Especially certain fetch libraries, they have certain nuances that might make or break your application if you don't understand it well. And that's quite an issue. So my library, I try to design it around the fetch API standard. There isn't anything extra given to you, it's just packaged in a nicer, more ergonomic way, I would say. Yeah, so which is why I feel like if you understand the fetch API, you can use my library very easily. Yeah, that's the key thing, honestly. Yeah, thank you.
Okay.
Yeah.
Asking a very layman question.
Sure.
So, you have to be recorded again. Okay, so suppose now I believe in you.
Okay.
I believe in you.
Thank you.
And I want to build a trading system. This.
Will it work?
I tell you, I want to. What are we going to do?
Okay. Of course, like I to be honest, right? I don't know what people will consider whether this is production ready or not. But personally, I use it for all my own projects, and I use it for my company's projects also, and it has all been working fine. So I guess that's what I can say about whether is it production ready or not. Yeah. Does that answer the question?
Not really, but
okay.
So you know the kind of data that we deal with is like is live. So every second you have
streaming data, you mean?
Yeah,
is
streaming.
Okay, so if you want to do streaming data, as long as the fetch API supports it, which I'm not wrong, it does support it, you can use my library to do so, because my library isn't implementing something on itself. It's just an abstraction layer on top of the fetch API to make it easier to use. So everything that you want to do with fetch, let's say data streaming or whatnot, as long as it's supported by fetch, it will work with my library. Yeah.
I think we can discuss more.
Yeah, sounds good. Any other questions? Yeah.
I think I just checked the code is correct, but the APM, I'm not sure who published that.
This one? Yeah. Oh, I published it.
Is there a different username?
Oh, no, it's simpler fetch. SIMPLER. Dash fetch.
On the web, it's having a different Git user.
Oh. Let me check with that later to see why is that the case. But yeah, let me check with you on that. Anyone else? Any questions? If not, thanks for your time, everyone. Hope you wanna